Hey guys, I'm back again to lead you guys on more pointers, arrays, and strings. The last video I tried to explain and give some details about pointers, arrays, and strings by covering the previous 0x05 pointers project. Alright, today I'm going to take you guys on this very new one called the more pointers, arrays, and strings as a continuation of where we stopped, okay? We're going to hit straight to the task ahead, alright? The first one here says write a function that concatenates two strings, and then using this prototype right here. So let's kickstart it. All right, on my replit, I'm gonna create a replit, and let's call this replits more underscore pointers. Okay, create replit. All right, so this is my main.c file, and of course we're gonna create our main.h and then in here let's define the right thing that is supposed to do inside here. The first thing I'm going to do is to say include stdio.h, and then I'm going to define hash if not defined, if not def. Let's call it main underscore h hash define main underscore h. Okay, and then you got to end if. All right. So firstly, let me get this prototype right here and paste, but I'm not going to use exactly what you have in here. I'm going to change some things. So pasting here, I'm going to call mine concatenate. So I'm going to call this con for concatenate. And then right here, I'm going to use just A and B. I don't like too much stress. Okay. So hence we're going to create a file and let's call it concat. All right, concat.c. And in here, let's get the prototype here. Get this, copy these, and then go here, hash include main.h, and then I'm gonna have the prototype here, or the function I'm gonna use to call open this. Okay, then in my main.c, let me change this to main.h. Okay, we are set to go. Okay, now what this simply means is that this project means is that now you have two words here, S1 standing for hello, and then the S2 stands for world. You're going to write a program such that this hello and the world will be joined together. That's the meaning of concatenation. Bringing two strings to come together, passing it to one variable. All right. So let's see how to do that. Okay. So the first thing here in my main.c, I'm going to create two variables, char, and then the first one, let me call it C1, and then I'm gonna call the C1, let's say the C1 is going to be equal to engine, the space, and then the second one here is gonna be char. Let me call this one C2. Okay, and then I'm gonna call this technology. Okay, so we have engine technology. Okay, so what you're supposed to do is when we want to print this, we can just concatenate these two strings to print at the same time. Okay, so let's go to concatenate and write the function. Now, what that simply means is that you have to loop through the first character variable, which is a. So I'm going to say integer I, and then for I, of course, equal to 0. Then I'm going to pass my a into I, not equal to null. Of course, I will increment I plus plus. Okay. So at this moment, we are only trying to find out the last value for the character pointing to A. So now I'm just going to terminate the for loop without actually writing anything. So the second one I'm going to do is to run another for loop. So I'm going to say for, let's say integer j equal to 0, and then b of j, okay, not equal to the same thing, null, and then j is going to increment j plus plus. Okay. So now at this moment, what you're going to do is the last value of a in I will be continued with this j. So that means that a of I will continue from wherever it stops by imputing or appending the values in the b pointer. The value here will be appended to a of I, meaning that the a of I will increment. So the b of j will be added to a of I. What this means simply is that the first time j is 0, so the first element or element in the string, which is, let's go back to C, which is the T, is the technology, the first element will be added to I to become engine T. So for the second time, it's going to be added again to become engine TE continuously until it gets to the end. And then, of course, the I must increment for it to be able to accumulate that value. All right, when you're done with that, you will have to return A. All right, whatever you have as a result of A got to be returned back to the function that you called. Okay, so let's at this juncture, let's call that function we created. That's the con. So here I'm gonna say con. Now you're supposed to pass two parameters to that, A and B. So what I'm gonna pass is C1 and then C2. All right, so let's run the program and see what happens. Stack smashing detected, terminated. Okay, what this actually means is, now look at this. When you declare a variable, an array, and then you don't specify the memories that's supposed to be allocated, the program or the compiler will allocate a specific memory that is enough for whatever you pass to this very character. Now, example here, we have 0, 1, 2, 3, 4, 5. So what is passed here is 5, though it is not visible. All right. So whatever you pass inside here as a string is a determinant of what will be allocated to this memory. But you can extend that using a dynamic memory location called malloc. But for now, we're not dealing with that. So we're going to use static memory location. So let me say 100. So that you still have some space remaining. When you want to concatenate, it will add to the value you add here. So if I run this program again, I'm supposed to see engine technology, but I can actually see that because I did not apply my print A. There was nothing here applied to actually print that to the standard output. So what I'm gonna do here is to say print if percentage %, because it's a string, and let's add a new line here, /n, comma, then you're gonna pass this parameter right there. And of course, we gotta close the two brackets. So if I run here now, you can see we have engine technology. So these strings has actually been concatenated to each other. But however, if I choose to print something like this, just C1, you realize that only the engine will be printed on the screen. You got engine. All right, so that's how to concatenate strings. Okay, I think we're done with that very one. Let's go to the next one. It says write a function that concatenates two strings. Okay, but there is a little discrepancy between the first one and the second one. In here, the function is similar to the first one, all right, except that it uses at most n bytes from src. This means that you're going to print everything that desk has. But now for the src, you're not going to print everything, but you're going to print regarding the number that is passed to this parameter. Okay, so let's see how to do that. I'm just going to edit this one to salvage that situation. So right here, I'm going to add something here. Let's say I'm going to add integer n, and that's what is given here, integer n. Yeah. So let's just have a prototype on this. I'm going to copy this to my main.h. So let me paste it here. Okay. And then let me change this to con2. All right. Let me change it also to con2. Okay. Now, it is actually almost the same thing, but what you're going to change is just this place. Okay. So in here, I'm not going to check for what is inputted in the string, but what I'm going to check here is j, all right, less than or equal to the n that is provided. So whatever is provided as an n will determine how many times I will loop through and then add the values to the b. Okay, so I think every other code should remain like that. Let's try to print and then con. Let's do something like this. Let me call this result, raise to be result. Okay, then I'm going to declare a character called result, and then let me just pass something like 100 inside here. All right, and then right here I'm going to say that my result res will be equal to con2 open brackets. I'm going to pass the first one c1, I'm going to pass c2, then I'm going to pass, let's say, 3 to that. Okay, so we got an issue here. And red type character 100 is not assignable. Yeah. Okay, what you're supposed to do here is to declare your res as a pointer, which is going to be pointing to the array of string. Okay, so that's settled. Now, if you run this program, now you can see that we have engine and then take just 1, 2, 3, 4. That's 4 because the first value here it's 0. So 0, 1, 2, 3, it's actually 4 elements. Okay, but if you look at the project, all right, and then if you look at this, you notice that the first time it's printing hello, which is s1, and then we have hello here. All right, the same thing like ours printing just c1 to have engine. Okay, and the next one here it prints s2, which is supposed to be world. Of course, we have it right here. But here we say ptr, exactly what I've done right there, character pointing to ptr, and ptr equals to the function that was called into s1, s2, and then 1. So if I probably write 1 here and run, you'll notice that my program prints two values at the same time, while in here it's printing w, only one value. Okay, so how can we correct that error? The simple way to do that is to subtract a value from your n. So you go to your concat.c and then say that j is less than or equals to n minus 1. So that if I'm passing 1, it will subtract 1 from it, and then I'll have 0, which is actually the index that will print the t. So if I run this now, I'm going to have just engine and t, okay, because I passed 1 here. So if I should pass 2, it's going to be engine.te. Let's run that. You can see engine.te. So that's how you can manipulate this very task to have your result. I hope you understand what I'm trying to portray. Okay. The next one here is string and copy. All right. Write a function that copies a string depending on the number specified. Now, we've done this in the previous video. You just go back there and check on it. The only difference is to add your n. And just like this very project, it is similar. The only thing you need to declare is this j less than or equals to n. And then when it's copying, it's going to copy only the value that is associated to the specified integer, which is the n. Okay, so that's just a similar thing to this. And then at the end of it all, you're going to like copy. You're not going to increment it, but you're just going to copy that value to another memory address. Okay, let's move to the next one. That one is easy. Okay, in here, write a function that compares two strings. Okay, write a function that compares two strings. Now, let me just use the main.c to illustrate something. Okay. First of all, there is something you need to understand. What does string compare return? If you look down here, what you're seeing here is minus 15, 15 and 0, depending on what they were trying to print, and is returning a value of integer data type. So you can simply check on your man page, let's say man, strmp, string compare. In the synopsis here, we realize that you got to pass two parameters. We have the first character and then the second character, which is going to compare. And then you can still use string and compare, meaning that you're going to specify the number of size or the number of element that you need to utilize when you're comparing the strings. Okay, so if you look down here, the return value, it states that the string compare and string and compare function returns an integer less than, equal to, or greater than 0 if the first value, that's s1, or the first n byte thereof is found, respectively, to be less than, to match, or to be greater than s2. Okay, let's look at the position of that definition, what it really means. Now, let's have here print f and then %d / n new line, compare for me c1, string cmp compare, and then I'm going to pass c1 and c2. Okay, so now this is a string header file, so I'm going to add here hash include string.h. Okay, so let's run this and see what happens. Okay, we have minus 15 when you try to compare these two strings, if they're the same or not the same. But what is the meaning of minus 15 first? Okay, now let me try to explain this in a very simple string. Let me just use a character. So if I have a here and also have a here, so if I run this program, I got 0 because a and a are the same, so I'm gonna have 0. But what if I have something like b here and then run the program? You see I have 1. So there's something significant about those values. A and b, the difference is 1, right? Because after a we have b, which is a difference of 1. So that means if I should have something like c here, the difference should be 2, if my assumption is right. So let's try that. Now you see the difference is 2, right? So let's try something like d, a, b, c, d. It's supposed to be 3, right? So let's try that. Sorry, let's have c here and then try to check that. We have, okay, 2. That's a, b, c. That's 2 places. So let me try to say I have d here and then run. I'm gonna have 3, right? Okay, we have 3. So that means that if I should have z, which is the last alphabet, I'm supposed to have 25, because the difference between a and z is 25, right? Okay, so that is the meaning of those numbers you're seeing. But we had minus 15. What does minus actually mean? If peradventure, let's say I have a here, okay, and then I have z here, that means I'm supposed to have a reverse of 25, which is minus 25. I hope you understand the logics behind this string compare and the values you have. So that means if you look here, the space between h and w, you will discover that we have 15. The difference between h and w is 15. So that we have minus 15 here. And when it was inverse, and then starting from S2 here to S1, we have 15, because here if just inverse the W and the H, that's what it means. And then if you are comparing S1 and S1, of course the value remains H and H, so that's why you have 0 here. Now you are asked to write a program to perform that same act. That's it. Instead of using the string compare, you're going to write your own program to do the same thing that string compare does. So let's take this off and write our own code to do that. So I'm going to remove this here, and then I don't think I need this again, so let me take this one off. So let's create a new file called compare.c. Okay, and then here I'm going to have, of course, my include main.h, and then let's get a prototype here. No, let me use mine. So let me say integer com for my compare, and I'm gonna say character pointing to x and then pointing to y. You know, in engineering field, we always like to find x and y at all times. Okay, so let me get this into my main.h. Okay, let's try to write the code to do that. Now, what you're going to do here is simply to checkmate the two values when they're iterating. Now, this is what I mean. I'm going to declare two integer data types. So I'm going to call it int I and j. Okay. And then for the int I, for I will be equal to 0, while I is equal to 0. Of course, the j should also be equal to 0. J also is equal to 0. Okay. And then now my x of I not equal to null, or my y of j not equal to null as well. Then I will increment, and of course j will also increment. There are different ways to actually do this. You can choose to do it separately, but I think this is gonna be fast. Okay, then I'm gonna open a block, and then I will say, so in the block you're gonna compare the values in x of I and x of j, or sorry, y of j, if the value of x of I is the same thing as the value of y in j. Okay, that means while I is 0 and x is also 0, check to compare if the values present in this very first index, the 0 index, are the same. If they are the same, what will you do? Just continue. All right, continue checking for others. All right, that's what it means. But otherwise, else it is not the same. Okay, what you simply do is to subtract the value that is present in x of I from that of y of j. So I'm going to have x of I and then minus y of j. Okay, so we got an error here. Let's see what that means. It says expression result unused. Okay, so since it is not unused, let's just do something like this. I'm gonna say results. Let's just use res, or let me use something else. Let's say c underscore result, it's equal to whatever value will be passed here. So I'm gonna declare that here. It's gonna be an integer data type, so I'm gonna put it here to be c underscore res. Okay, then when you check whatever value you got, return the value to the function. So return c underscore race. Okay, I think we are done with that. There is an error here. It's a warning message. So okay, we need to return something. So let's just return 0. All right, that is settled. Okay, so let's go back to our main and try to call the function. Just like when we use the string compare, we're going to do the same thing. So I'm going to print f, and then I'm going to pass %d. Let's have a new line here. And I'm going to pass the function. I think we use compare, com, okay? Com. And then pass the value of c1 and then c2 to the program. Okay? There's supposed to be a comma here. Okay, so let's run that and see what happens. Okay, you can see we have minus 25, exactly what we have the other time. So let's see if I have a here and also have a here. We're supposed to have 0, right? So let's run that. You can see we have 0. So that is how to actually write a program that will perform the same function as the predefined string compare function, which we actually noted a few minutes ago. All right, let's move on. Okay, the next one here says write a function that reverses the content of an array of integers. I think we've passed something. Okay, so in my previous video, we did something of this nature, right? When we wrote engine technology, and then we wrote a function that actually reverses engine technology to y or the likes of that. So the same thing is applicable here. The only difference is that you're going to specify the number of the element that you're going to reverse. Okay, so take for instance we have these 0 to 1337, and then you ask to reverse. You start from the 1337 to 0. It's just opposite direction. So let's see how to do that. I'm gonna call this verse.c hash include main.h. Okay, so let's get the prototype here. I'm gonna use the same thing here. Copy this and then paste it here. But I'm gonna use just rave, and I don't like long function names. So open the block. Okay, so let me add this to my prototype. Copy this and then paste it in my prototype here. Okay, let's try to write a function that will reverse whatever is inputted to our standard input. So first of all, we need to, let's go to main.c, and then let's have something like an integer, and then let's have something like number. Then we're going to pass some element in here. Let's have 3, 4, 5, 12, 8, 90. Let's have that. All right. So our program that you want to write will actually reverse. Instead of printing from 3 to 90, it's going to print from 90 to 3. I think that's the same thing right here. It's printing from 1337 to 0, from here down to the first value. All right, so let's get to business. Let's go to our reverse here. Now the only thing you need to do is that the number is gonna be given, which is the n. So you're gonna work with that number. The first thing you need to do is to declare a variable called I, or anything you like, maybe like count, or let me just use something as I've been using this I for quite a number of times. So let me use len at start now. So now for, all right, len it's equal to n. Now what does that mean? It simply means, let's say you passed a value like 5. You pass 5 here, so it's gonna print from 5 and then it's gonna go down. So 5, so len it's equal to n, and then your len will be greater than or equal to 0. All right, then length will decrement. So we have length minus minus. Okay, so right in here, what you're gonna print is a. So I'm gonna say print f, and then percentage d. Okay, slash a, and then into length. Okay. So what this means is that for the first time, let's say length was given as 5. It's gonna pick the 5th element of the array and then print it downwards. So okay, let's run this and see what happens. Okay, we got nothing happening. Let's go to the main.c and call the function. The function is called ref. So I'm gonna say ref number, and then I'm gonna pass something like 4 as a size that will be reversed. So if I run this, I got 8, 12, 5, 4, and 3. So let's do something because it's jam-packed. We can't really separate them. Let's go to reverse and then add something like a comma and a space here. Okay, let's run that again. So you can see we have 8. Let's go to the main. We have 8, we have 12, we have 5, we have 4, we have 3. So it's reversing. Now, something is wrong somewhere. If you look at this program, you have 1, 2, 3, 4, 5, 6 elements. So if I pass 6, I'm supposed to have 6 elements printed on the screen, but I'm going to have something like 7. Let's see to that. I have 1, 2, 3, 4, 5, 6, 7. There's a garbage value that is printed here. Because after 90, there is nothing else to be printed. So it's going to pick any random value it finds in the memory to print. So you can actually write a conditional statement such that if n if the value passed is greater than the n or the value expected, the size of n expected, you should flag an error or try to omit some things. But for now, we're not told to do that. So what you got to do is look at this first. We actually have 6 elements, all right? So putting 6 here is not wrong. It's correct. It's supposed to print 6 elements for us. But remember that an array starts with an index of 0. So index of 0 plus 6 will make it 7. And hence it's a false program. So let's try to correct that. Go to reverse and then let your length be equal to n minus 1. All right? So that means if I should pass 6, it simply means 6 minus 1 is 5. Which is going to print the right thing. So if I run it now with the 6, it's printing the right thing for me. 98, 12, 5, 4, 3. So I can choose to say maybe I want to print 2. That should only print 4 and 3. Okay? So that's how to reverse strings. I hope that was pretty simple too. The next one here says write a function that changes all lowercase character of a string to uppercase. All right. Okay, so let's see how to do that also. I'm going to create a new file here. I'm going to call it upper.c #include main.h. Okay, and then the prototype is here. I'm just going to call this upper alone. Okay. Okay, now you can't leave char and a pointer like this. A variable must be added to it. So ensure to correct that. It's just a temptation for you. So let me just use C to cover that up. So in my main.h, I'm gonna have the same thing in my main.h. So let's get this. Go to the main.h and then paste it here. All right. Okay, so this is just very simple, but just trickish. Okay. Now let's say you pass a value called a or hello in lowercase. It is supposed to change that value to uppercase. But how? I'll explain that. First, let's just try to iterate over the string you pass. So let me say for integer I, it's equal to 0, and then C of I don't know why I love this I, is actually not equal to null. Then I increment I plus plus. Okay. Right now, what's going to happen is that every C of I should change to C of I. Now, let me explain something here before I continue. If you look at, let's just make some Google search on what you call ASCII table for uppercase character. Okay, so let's open this get4geeks.org. So if you open this, you can see some ASCII table here. Let me just scroll down to A and capital and lowercase. All right, so in here we have that the character A, capital letter, is denoted by the ASCII code 65. And then the small letter A is denoted by the ASCII code 97. All right. So now that means that if I write something like, let's come back to our program. Let's go to the main.c. I'm going to take this off. Okay. Now, if I write something like, let's say, integer, and let's say number, equal to 97. Okay, let me try to print that number using the char, the percentage %C. Okay, and then I pass number. Okay, so let's print this and see what will happen on the screen. Upper.c. Okay, let's terminate this first. Go back and then run it again. Okay, so you can see that we have A, right, printed on the screen, but I actually wrote 97 here. And what if I choose to use 65 to print? I'm going to have capital A. Okay, just like what you've seen here. All right, so now between 65 and 97, is it 97? Let's confirm that again. Sorry for that. Okay, 97. So between 65 and 97, what is the difference? Okay, let's simply run that and say printf percentage %d. So I'm gonna say 97 minus 65. Okay, so let's see to that. I have 32. Okay, so the difference between 97 and 65 is 32. Okay, so now if I say that integer number 97, and then I say minus 32, okay, and then try to print number using the character data type, let's see what we will have on the screen. Okay, you see we have capital A. I don't know if you're making sense. I'm trying to explain something here. Okay, I have capital A. So that means that if I go to my upper.c, and then anytime you pass, let's say that your C of I, it's probably A, which was small letter. So if I should pass that A and then subtract it by 32, that should actually take me to capital A, right? So let's see if that will make sense before we continue. Return 0. Okay, so let me go to my main.c now. And then let's say I have a char data type, and let's say I have something like ch here, and then I'm gonna call this, let's say, let me just pass a alone for now. Okay, and then let me just try to print this. If I print this now, print f, and then percentage, let's say c, then let me print ch at the location of 0. Okay, if I run this, I'm gonna have the small letter a on the screen. Now if I choose to change this to capital later, I'm gonna call my function. So I'm gonna call upper, and in the upper I'm going to pass the ch into the upper. Okay, so now let's reprint it again. So print f, percentage c, new line, and then comma, trying to print the ch again at index 0. Okay, if I run this, I'm gonna have capital later. Of course, you've seen that. So that's how you can convert from small letter to capital letter. So how do we now loop through if, let's say, we have more than a particular character? So we have something like A, B, and C. Okay, if I put one here, of course, should give me capital B. Noted. If I put 2 here, it's gonna give me capital C. Okay, so how do you now print capital A, B, C? Of course, you need to loop through. So I can simply say for let me use something else. For count is equal to 0. Ch into count. Further, we got to declare count as an integer data type. So int count equal to 0. And then ch count not equal to null. And then count increment. All right. So while you're incrementing it, try to print the values in capital letters. So if I run this, I should have capital ABC. Let's take up this new line here. So we have the ABC on a straight line. So you see I can have capital ABC. But now I got something to show you. Let's assume this A was initially capital. Okay, then let's run the program. Now you can see that instead of it to print the capital A, since it's already capital, it is changing to exclamation mark. I leave this task for you to write the program and leave it on my comment box, such that if the program sees a capital letter while looping through, it should print that capital letter. It should not change it to any other thing, like what you're seeing here. Okay, but if it does not see the capital letter, it should change it to capital letter. Write the program, drop it on my comment section. You got a gift from me if you have it correctly. Okay, so let's go ahead to the next task. I believe that has answered the question for this very task. I think this is the last one. Okay, write a function that capitalizes all words of a string. Okay, in here you're asked to write a word or a program such that each first letter of a word should be capitalized. And then the separators is comma, semicolon, dot, and the rest. That means if your program meets a comma along the line, just ensure that the next word coming will be capital later, or semicolon, or the rest of these parameters defined here. All right, I'm gonna do this in my next video, and then the task 7, I think that's the last part for the mandatory part of it, and probably I may add this task 8 to explain it. Then that's gonna be all for this very more functions or more pointers. For now, thanks for having me right here. See you in the part 2 of this video. Bye bye.